So last time we looked at the law of cosines and we used that to help us solve triangles, particularly when we were given either all three sides or when we were given two sides and an included angle. Now, what about when we have two angles and a non-included side, or we have two sides and a non-included angle? What about in those cases? In those cases, we can't use the law of cosines in order to solve it, because if you look at the way that the letters are arranged and which pieces of that are given to us, we're only going to be able to use law of cosines if we have two sides and included angle, or if we have all three sides. Now, once you are able to figure out more information, you might be able to go back to using law of cosines when you are solving a triangle. But when we do have one of these two last cases, this is where we're going to be using law of sines. So here's law of sines. In any triangle, ABC, using standard notation where you have all the angles labeled with capital letters, all the sides opposite each corresponding angle labeled with the corresponding lowercase letter, then you can use this. A over sine of A is equal to B over sine of B, which is equal to C over sine of C. Now you'll notice that there are two equal signs in here. You do not use all of these at the same time. It's just telling you that all these ratios are equal to each other. So what you could end up using is you might just use the first two ratios, A over sine of A equals B over sine of B, and use that to solve. You might just use the second two ratios, B over sine of B equals C over sine of C. You could also use A over sine of A equals C over sine of C, right? So in any case, you're always setting up a proportion. So whatever you end up using should only have one ratio on either side of one equal sign. Let's go ahead and look at an example. So here's a triangle, and the information that's given to you is angle B is 20 degrees, angle C is 31 degrees, and side B is 210. Now if you draw this out, you can see that angle B and angle C, those are two angles, and 210, that's a non-included side. Okay? So, in this particular problem, it says, find the other angle measure and the side lengths. So, in other words, solve this triangle. So let's go ahead and see if we can find the last angle measure. So the last angle measure, well, if we have two of the angle measures already, we can easily find the third angle measure, right? So that's just going to be using the triangle sum theorem. 180 minus the 20 minus the 31 gives us 129 degrees. Okay, so angle A is 129 degrees. Now we still need to find sides A and C. So side A, in order to figure that out, well, let's see, what information do we have? We have angle A, we have angle B, we have side B, we also have angle C. We have a lot of information here. But since we're trying to find, let's say we're starting by trying to find side A, we want to make sure that we use A over sine of A. Now in terms of what's left, we don't know what C is, so we're not going to use C over sine of C. That's not going to be helpful to us here. So instead we'll use A over sine of A equals B over sine of B and fill in everything. So A over sine of 129 degrees is equal to 210 over sine of 20 degrees. And then we're going to solve for A. Now you can solve for A a couple of different ways. You can either get A by itself, so multiply both sides by sine of 129. That's fine. Sometimes if the unknown is in the denominator, it becomes more helpful if you think of this as cross multiplication. You will end up with the same answer. So cross multiplying, we would end up with A times sine of 20 equals 210 times sine of 129, and then you would divide both sides by sine of 20. And that comes out to be about 477.2. All right, so now we still need to find the last side of the triangle. Now with right triangles, when you were solving them, you could find the measure of the last side by using the Pythagorean theorem. Now it's tempting here because you see, oh, we have A, we have B, we can find C by using the Pythagorean theorem. Well, no, because C is not the hypotenuse. There is no hypotenuse here. You know that very clearly because none of the angles are 90-degree angles. So just be really careful not to fall into the trap of using a squared plus b squared equals c squared. So we're going to use law of sines one more time. This time we are going to try to solve for c. So let's use c over sine of c, and then at this point you can actually use either a over sine of a or b over sine of b. I'm going to go ahead and use b over sine of b, just because those were measurements that were given to us, just in case we messed up on some calculator thing for side A. All right, fill in what we know. So we have c over sine of 31 equals 210 over sine of 20. And then again, we're going to either cross multiply or multiply both sides by sine of 31. Multiply and divide that, and we get that c is about 316.2. So we were able to find, what did we need to find? We needed to find angle A, side A, and side C, and we found all three of those. All right, let's take a look at another example. Example 2. An airplane A takes off from carrier B and flies in a straight line for 12 kilometers. At that instant, an observer on destroyer C, located 5 kilometers from the carrier, notes that the angle determined by the carrier, the destroyer, which is the vertex, and the plane is 37 degrees. How far is the plane from the destroyer? Okay, so looking at the information that you have, and everything's labeled into this diagram already, what is it that we need to find? So we need to find how far the plane is, which is at A, is from the destroyer. The destroyer is at C. So we're looking for side B here. Okay, so normally we would say, okay, if we need side B, then you could say, oh, well, I can do B over sine of B equals, let's see, 12 over sine of 37, C over sine of C. But here's the problem. The problem is we don't have angle B. So what do we need to do to find angle B? Well, we're probably going to need to figure out what angle A is first, because we do have side A, and we do have side C, and we do have angle C. So that's going to allow us to find angle A, and then once we found angle A, we can subtract that from 180 and be able to find angle B. Once we have angle B, then we can apply law of sines again in order to figure out what side B is. Okay, so a couple of steps here. So again, first we're going to figure out what angle A is. So we have everything here other than angle A, right? We have side A, that's 5. We have side C, that's 12. And we have angle C, that's 37. So 5 over sine of A is equal to 12 over sine of 37. Now here's a case where you might find it helpful to think of this as cross multiplication. So 12 times sine of A is equal to 5 times sine of 37, and then divide both sides by 12. That will give us sine of A equals 5 times sine of 37 over 12. And then simplify that right-hand side, and we get that it's about 0.2508. I would suggest having at least 4 decimal places. Because here's the thing. We still haven't found the angle measure. We have to use the inverse sine function to get angle A. The more decimal places you have, the more accurate this will be. I think that having at least 4 decimal places will give us a fairly accurate answer for angle A. So take inverse sine of 0.2508, and that gives us angle A is about 14.5 degrees. Okay, so now we have angle A, we have angle C, we need to know what angle B is. So now we subtract 180 minus 14.5 minus the 37, and that gives us 128.5. Now we have angle B, so now we can go ahead and plug in for B over sine of B equals C over sine of C. We're trying to find side B. We have angle B now, we have angle C, we have side C. So B over sine of 128.5 equals 12 over sine of 37 degrees. And again, up to you if you want to cross multiply or if you want to just multiply both sides by sine of 128.5. We should end up with b equals 12 times sine of 128.5 all over sine of 37. And then go ahead and multiply and divide that. We get b is about 15.6. So, how far is the plane from the destroyer? It's about 15.6 kilometers away. Okay, so we've talked a lot about how to solve a triangle that's not a right triangle. When do you use law of cosines? When do you use law of sines? How do you use law of cosines? How do you use law of sines? We're going to move a little bit away from solving a triangle, and we're going to talk about finding the area of a triangle. There are two particular formulas we're going to go over. So the area of a triangle, you guys have probably used 1/2 times base times height to find the area of a triangle. Now, there's no problem with that. The only thing is we want to have more options because you're not always going to have the height, for example, of a triangle. And it might actually be a lot of work to figure out the height of a triangle. But you might have other pieces of information. So, this first formula that we're going to go over uses law of sines, or it's derived from law of sines, to get the area. So here it is. The area of a triangle is equal to 1/2 AB sine of C. So this is if you have sides A and B, and angle C will then be the included angle. So it's the angle that's formed by sides A and B. Now again, similar to law of sines and law of cosines, it really depends on how everything is labeled. So if, for example, you have it labeled so that you have information on angle A and you have sides B and C, then you can use 1/2 BC times sine of A. You could also use 1/2 AC sine of B. It really just depends on how you label your triangle or what other information you might have already. Here's example 3. Find the area of the triangle shown. Now notice that nothing is labeled here. So I would suggest labeling everything. It's up to you how you want to label it. The way you label it will affect which form of the equation you'll use. But notice that no matter which form you end up using, you should end up with the same answer. You've just labeled it differently, but you end up multiplying the same things. So let's say I label this side A, and this is side B, this is side C. Then I have to make this angle that's across from side A, angle A, the one that's across from side B, angle B, and the one that's across from side C, angle C. Okay, so it looks like we have sides A and B, and we have angle C. So we can go ahead and use the first form of this formula, 1/2 AB sine of C, 1/2 8 times 13 times sine of 130. And that should come out to be about 39.8 or so. So the area of this triangle is 39.8. Again, using this formula is really dependent on the information that's given to you. If you were given this triangle, it would be a lot harder, not impossible, but a lot harder to have to find the height of the triangle first before trying to find the area of the triangle. So 1/2 base times height is not going to be quite as easy as just using 1/2 AB sine of C. All right, there's one more formula that's used to find the area of a triangle. This one is called Heron's formula. And this is used when you are given all 3 sides of a triangle. So this is going to look more complicated than it actually is. There's going to be more than just A, B, and C in the formula. But if you have a triangle with sides A, B, and C, this is the formula that you would use to find the area. The square root of S, parentheses S minus A, parentheses S minus B, parentheses S minus C. Now what is S? S is going to have to be calculated before you can actually use this formula, but S does come from a formula that relates to A, B, and C. So S is equal to 1/2 of the sum of A, B, and C. S equals 1/2, parentheses A plus B plus C. Okay, let's go ahead and give this formula a try. So again, this formula is used so that in the event that you just have all three sides of a triangle, rather than trying to find, you can obviously use one of those as the bases, but rather than trying to find the height of the triangle, which is going to take a lot more effort, might involve using a lot more trigonometry than you actually need to, you can actually just use this formula to find the area. So first we're going to have to find what S is equal to. So S is equal to 1/2 A plus B plus C, so that's 1/2 of 7 plus 9 plus 12. That's equal to 28 divided by 2, which is 14. And then you take the square root of S times S minus A, S minus B, S minus C. We're going to fill in. So that's going to be 14 times 14 minus 7 times 14 minus 9 times 14 minus 12. So that's what, 14 times 7 times 5 times 2, which is 980. And then the square root of 980 is about 31.3. So the area of a triangle with sides 7, 9, and 12 is going to come out to be about 31.3 square units.